All right, thank you. Sorry about that. I can tell you about LLMs, but I can't get my screen to display. Guess what? You know what I'm only going to say it once, is I'm only going to say ChatGPT once, because I'm not using ChatGPT. I'm going to show you how you sort of code and how you get to the really interesting stuff of all this generative AI, chat, if you call it generically. I guess the Coke name, Coca-Cola, is ChatGPT, but there's just a lot more. And the one thing I will say is I put this together yesterday, so now I had a lot of material, so it wasn't like I wrote all of this yesterday, but this is going to be a pretty technical presentation, but it should work for anybody at any level. So what I want to say is when it gets real technical, just pick up on the meta points that I make, because I think you'll learn a lot. So don't, like, when it's sort of, there's all variants of like technical expertise in this room. So like, don't get freaked out if I go deep. Other people will sort of go with me deep. I'll have all the references and all that stuff. So I started playing with GPT-3 in 2020. I was in the middle of writing my book, or a little late in the book, and I thought, wow, this could be a great tool for research. And in GPT-3, that was 2020. It was really, the efficacy of it was very low. We call them hallucinations now, but it was useful, but not useful enough. And then when 3.5 came out, I tried it again, and it was a lot more useful, but still a lot of hallucinations and all. But one of the things I'm going to talk about, probably the most important takeaway in this presentation, is things called vector databases. And they really are a linchpin to what we do. And that's another meta point, write it down. And one of the ways I learned how to use all this stuff is I used my book to basically seed my book into a vector database, and then I could actually use all these conversations, all these sort of questions using GPT 3.5 and 4 and all that good stuff. I'll go through a lot of it. Some of it will be tutorial, but I'll stop saying meta point, sounds silly. But it's all about the data. Like, we can go and ask, the magic 8-ball, when I'm going to get married, when am I going to get rich, and all that nonsense, right? But the real interesting stuff is how can we put our incident data into this and make it useful? How can we get SOPs or really anything in our industrial, sort of IT, but anything, and actually make it so it doesn't leak out into the world and it doesn't hallucinate. So that's basically what this is going to be all about. Oh, that didn't work. So the agenda here is I'm going to do a little introduction about myself. Because I've got a new book, I'm going to talk just really briefly about Dr. Deming, and he was mentioned in the previous session, and then we'll get right into the generative AI landscape. Again, it's about the data. This is really important. Like, if you think like you might want to use this in your enterprise, and then if the demo gods agree, I'll do an actual demonstration. And all the images from here on in were built by Midjourney. So I kept asking questions like, draw me a picture of Dallas DevOps days and older building, and the pictures actually get better. So this is the first one is like, there we go. So that kind of missed the mark. Didn't really look like this, but all right. So just quickly about me, I think Willie did the intro. I've written like 12 books. I've done 11 startups. I sold the company to Dell. I sold the company to Docker. I was 7th person in at Chef. So big deal. The real big deal is my book. It took me 10 years to write this book. It is my white whale. It is the joy of opening up the box a week ago and finding 100 books shipped to me was better than the deal that I sold to Docker. Right, honestly, I felt pretty good that I sold the company to Docker, but like, it was a lot better opening that book and seeing my book. I've written other books, but I've co-authored. This was my book. So there's the book. It's out there. There's the code, whatever. Like, I would say you could help me put my kids through college, but they're already through college, so I don't know what that. Oh, so after this, one more sort of advertisement. I'm going to do an open spaces on something. I didn't know I was speaking here, so I'm not trying to hog the stage, but they asked me yesterday if I would do this. But I'm doing Deming's famous red bead game, and it's going to be hilarious. I fire people. And I give out prizes, and all on things that you have no control over. So that's Andrew Schaefer, that's Nathan Harvey, that was in Amsterdam. I had to fire Andrew. So one of the things I think is really interesting for us as we embark on this generative AI and all this stuff is what I wrote this article recently called The Rise of Shadow AI. So if you were playing around with early cloud, right, we had this shadow IT where organizations were just running out using credit cards, and we had this it took us 10 years to clean that mess up. So this article is about that, like, let's not let that happen again. You know, I think the CIOs are going to have to own this generative AI. I know there's a lot of confusion on who owns data science in the enterprise, but like if we don't sort of tell our organization, our leadership to get a handle on this stuff in 5 or 10 years from now, we'll be doing the same thing of cleaning up technical debt, leakage of data, all the things that we do really well of protecting. And I know there's a lot of like, well, we don't need it's kind of funny. Like this was the cloud thing. We don't need those IT people anymore. We can do it on our own. And like, that didn't turn out well. So a couple more articles. So let me tell you about Deming quick. If you don't know who Dr. Deming, you actually do, because basically you've heard one of his quotes. Not all of them are his quotes, so there's all mythology, which ones are quotes, but in God we trust, all others bring data. A bad sister will beat a good person every time. Laura's presentation about equilibrium, like it's systems thinking. He was the ultimate system thinker. And then system profound knowledge. And the reason I'm telling you this again, I used my book for what I'm about to tell you right after this slide. So I thought it was interesting. This guy had a profound sense of how to solve complex problems. And by the way, everything we do is complex systems, right? So he really boiled it down to 4 elements as a lens for complexity: theory of knowledge, epistemology, you could call it scientific method. I'm going really fast, so I want to get into the other stuff. Theory of variation, statistical analysis. You might have heard of statistical process control. If you get all that right, you're still going to get it wrong if you don't understand human behavior. Intrinsic motivation, extrinsic motivation, cognitive biases, and then, of course, the wrapper is system thinking is the core of anything we produce and try to handle with complex systems. Enough about Deming. See, the pictures are getting a little better, huh? So the landscape is crazy. Like yesterday I added 2 new things, right? I mean, I suspect right now I could add 2 more things. But there's good meta points like for our world, which is, first off, this H2O.ai is really interesting. It's a cloud based on thing. I've been able to use it pretty effectively. But NVIDIA and ServiceNow are working on something. If you heard about Hugging Space, you should check it out. It's emerging, a lot of investments. Google, a bunch of the big cloud providers invested in it. Databricks is trying to sort of give you the enterprise version of these sort of generative AI data, large language models, whatever you want to call them. If you've been paying attention, Facebook is open source Llama 2. Recently, they're claiming it's just as effective as GPT-4. I don't know. We'll talk about vector database. I'm a big fan of Mongo. Mongo has produced a vector database, and I'll tell you later why I think it's better than the other vector databases. Pinecone is a vector database. They have partnered with Azure, so now you get it as a service. I think you're going to see a lot of this. You're going to see like Amazon, and probably already, but Amazon and Google will actually start eating up the ecosystem, kind of like what they did with cloud. Like cloud, they created RDS instead of MySQL, right? So I think you'll see a lot of these things turn into services. Cohere, there's sort of a big 3, and it's my theory now, so I don't care if you think I'm wrong, is that there is a big 3. There's OpenAI, the ChatGPT, I lied, I said it twice. And then there's Cohere, which seems to be seemingly aligned with Amazon, but that's the weakest link. And then you have Anthropic with Claude 2. They seem to be gravitating to Google. I don't know if that's going to play out that well. And then the really interesting stuff is some of the stuff within the last week that OpenAI announced. And one is to be able to tune your own models. Now, I'm not going to really talk about it. It's something called LoRa, and it's really interesting stuff. And so the idea is you send your data, instead of getting back GPT 3.5 or 3.5 Turbo, you actually get a sort of another model that's been a binary extension. But there's a token cost, so I don't know. It might be cheaper to just create your own sort of what I call vector database. And I know we haven't gotten to that yet. And then they just 2 days announced an enterprise edition, which just seems like it's really the fine-tuning update for enterprise, just more money. Cohere, and then Amazon Bedrock. So this is an important screen for like trying to understand the architecture here. So on the far left, one of the things you sort of learn about like how to use these tools is orchestration. Like, because you're not going to just use one model. You again, all right, I'm going to throw out that I lied about ChatGPT. In ChatGPT, you have this like simplistic view of what's going on. You type in questions, answers. Maybe you've got a little more advanced where you build prompts. But the real sort of power here is having multiple models or multiple interfaces. Like you can, I've got some demos where I will ask, and you do this all in code, right? I'll ask, what's the weather like today in Boston? I'm a tourist. What would you recommend me to do? Well, there's no LLM that has the weather today in Boston. So what I do is I chain and orchestrate an API called weather.com, and then it gets seeded into the prompt, then it goes to the LLM, and then it tells me it's rainy and wet, you probably should go to a museum. So you're going to see a lot of that. There's already ones with SQL, there's all, you can invoke, all this stuff about GPT is terrible at math. Of course it's terrible at math. It's a vector database. 5 and 11 it's a nearest neighbor model. you don't do math that way. So the orchestration is interesting, and probably the most popular and well-known is LangChain. And LangChain is pretty much the lingua franca right now, although I will say that my saying about LangChain, and this is true about just about anything else, is if it's working for a month and it breaks, wait 2 days and it will work again. So, and I thought that was funny. And then in the middle, there's the vector database. I told you these are the most important thing, right? What you're doing with vector database, so you have GPT, let's say GPT 3.5 or GPT 4, and these are big trained models. I think almost everybody knows sort of like what they are. My aunt, who doesn't even know what a computer is, knows this. And, but the thing is, what you get to do with vector database is you create your own subset. And think of it as a prefix that you're sort of adding on an extension. So you get to put your data in this thing. You basically create it in the same format as the model that you're using. Let's just say GPT-4, but it could be Llama 2, it could be Cohere, or Claude 2. But you basically build your own data store, and you put your data here. So what I did is I put my book in here, and I attached it to GPT-4. And what's really interesting is it will look for things. If I ask my questions about my book, I won't get hallucinations. I'll get data from the thing I primed in the vector data store. And then if I want something like, can you give me further research, then it will go out to the GPT-4 model. So there's a number of Pinecone is probably the leader right now. ChromaDB is a very simplistic, like every Hello World has ChromaDB. Again, I'll show you later why I like the MongoDB. It's the way they do metadata separation. And then this Willis is pretty interesting. They actually built, they must be DevOps focused. They built like a Kafka Kubernetes implementation of a vector data store, which neither of the other two seem to do. On the far right, so the upper left, you have sort of what Amazon's doing. You have Cohere, you have Anthropic. If you haven't tried Claude 2, it's pretty cool. You can actually load in a PDF right into it, and it will summarize it. So you don't even have to write a bunch of code like I'm doing. And in the bottom, you have the Llama 2. And then on the far right, I'll end the presentation with tracing and evaluation. This is going to be another sort of interesting thing to think about is how do you do observability, tracing, and then really just efficacy. They don't use the word efficacy, but how do I know if I make changes that I'm getting the same level answer than I got before I made a change? They call it evaluations. So there's some interesting models for doing that. I mean, if you want to leave now, you can. Is anybody having fun? Raise your hand if you're kind of having fun. All right, good, okay, fair enough. This is really cool. We did a hackathon last week. We pulled in some of Patrick Dubois, some of the early DevOps folks to try to get our head around it. And one of the guys had built this, and he worked for Enterprise Vision Technologies. But this three-tier or three-layer cake, if you will, for how we might have to manage this. You'll have at the top these vector data stores. And then, like I said, you'll sort of attach those, and it's not really attached, but you sort of combine them with a foundational model. So foundational models are like your BERT, your Claude 2, your GPT-4. And then what's interesting in our world, we want to do things like governance, prominence, and cleaning. Like, for example, if, let's say, most of this presentation I'm giving you today is about text. There's an interesting narrative of multi-mode, right, like audio and visual, but I'm not going to focus on that here. But let's say that we're doing the code model, right, and we wanted to just build our own version of Copilot because we got really fancy code, and not me, but like, like a financial trading or algo trading, right? Maybe some of that you want to introduce in a model, but you might have a whitelist for certain repos that should never get into the model. So that you can, that's the way you want to think, or like, say you're Nike, and I'm not saying Nike student, and you never want like James LeBron's contract is shown up in the wild. So this is a place where you might want to sort of whitelist certain things, and then you want to do sort of red teaming, and then you fine tune. And then remember I talked about orchestration on that right there is where something like lane chain, and the theory is a lot of people will write their own proprietary version, and that you can do those things like interject like Jira, JQL. Or whatever, right? Like you're going to, like remember I told you the weather example? So imagine you're sort of chaining through things where one, I'm going asking questions, second, I'm going to an internal API, third, I'm going to another model to ask a different question. Like I could have a model for incident, a model for SOP, and a model for PSI DSS. And somewhere in between there, I've got an API call to like, should we do this? Maybe ServiceNow, right? And then on the bottom, it gets really interesting in that, you'll see in models where we build cache, because you're going to, like in a large enterprise, you're going to want to pay what they call the token cost for every call. So you'll see these models where people will create a cache. So in a large enterprise, it's the same question over and over. And then on the left, there's sort of there's another layer of, the idea of a critic. Did the answer I got before I make the change, is it still got the same sort of evaluation or sort of effectiveness as the last time it runs? So you're going to see a lot of that. And here's where you can also add, like in the code example. People are talking about, like, if there's proprietary code that whitelist should never come in at the second level, can I recreate that code at this level, right? It's an interesting question, right? If it actually creates that algo or code, something stuck through the system. And then you could have tracing and all that good stuff. So, but here's the thing I was saying earlier. Like, the real interesting thing about this stuff is the vector database, but then it becomes, the people who are working with vector data. Anybody working with vector databases here right now? Oh, that's terrible. No, not in that, like, you must be all lost at this point. No, but the thing is, like, what you'll see is you learn how to use this. All the hello worlds are just slam your data into vector database, and they'd ask questions, and it's glorious. The thing they're not telling you is different types of data are going to require a data strategy, sort of an inline ingestion. You have to think about, like, if it's a transcript from an audio, like a war room or incident, versus an SOP versus something that has Markdown, like, you're going to have to think. And so the first step then is how you split the data, and it's just code, right? And it's called chunking, because the way you chunk the data is kind of how it's going to wind up in this vector store. And you can chunk by sentence, and you can chunk any way you want. But you can chunk like sentence by paragraph by page. And this is going to create so at the end of the day, it's a nearest neighbor, or it's basically a sort of similarity. When you ask questions in GPT, it's a very sophisticated, like ridiculously smart people built it, but it's really just finding nearest neighbor to give you these answers. It's probabilities. So you need to think about where you want to chunk what kind of data and put it so it's near to this other data. And then when you pick a vector database, you have to align what they call the embeddings, because basically all of the vector databases have an embedding schema. So if I'm going to use GPT-4 and I want to use some vector database, I need to find out the schema that GPT-4 used so it's consistent. So, and again, and you might have multiple options, so that consistency or that choice can determine another sort of layer of how effective the questions that you ask against your data and what you get back. And then there's this whole point of metadata, which is really interesting, is that a lot of people who think about like these vector data stores, you put your data, like again, I'll go back to my example, and I'll show you. I put my book in there. I took the whole PDF and put it in there. Right, and I can ask those questions. Can you give me a summary? Give me a book report. And it does all this stuff, like, miraculously. But the question that comes up is, like, what happens when I want to put all my incident data in one of these? So now I could go ahead and stuff all the incident, but then if I try to, it's like the thing I said earlier, like, oh, GPT does terrible at math. It's not going to do good on relational or index searches either. So if I say slam all, it's like, let's just say I'm keeping all my incident data in an LLM, in a vector data store. The question of, like, give me all the incidents by Bob over the last month on Mondays and Fridays. That's a terrible question. You're going to get terrible answers. So the question you have to ask is, I need to separate stuff outside of the LLM somewhere else. And this is why I actually like Mongo. So, because the way Mongo's model is, they're document objects, JSON objects, and basically all your meta is there, and then all the embeddings are part of it. So I can go ahead and slice through and give me all these things. It's like the name, the department, the network, whatever, the category, and it'll give me all the embeddings and just give it to me as one. Then I can ask all questions like stuff that's in the LLM. What actually happened? Who said what? Who answered first? And then, so that's sort of the data portion. So separating out the meta somewhere from, what this Pinecone does sort of labels, sort of like Amazon did labels, right? So you can put labels on, and it's a lot more simplistic model. And then you get into chaining, how you query, and this gets really interesting too. And then last but not least is observability and tracing. Like, how can you see what's actually going on based on the data choices you make? And so here's an example of most of the things you just talked about. A lot of this is called Retrieval Augmentation Generation, or RAG. So I have some data, PDFs. They could be transcripts. I mean, LangChain has it has a Slack integrator, it has a Jira integrator. I mean, you name it, they already have an implementation for pulling it in. I find just converting everything to a PDF is the simplest way. And then you put it into, and you take that data, and you basically write code to split it in what they call chunking. Remember, chunking is, I want to get the right mixture of the data, like that paragraph or whatever, so they get located in sort of a nice vectorized space. I'll show you some examples. And then once you've done that, then you pick an embedding that you want to map to say, this is how I'm going to set the embeddings. And the embeddings basically creates the pure vectors. And vectors are basically just floating points in a sort of three-dimensional sort of model, right? Again, you don't ever need to know that. And then after that, you have the queries that you're going to do, what you call prompt. You've probably heard of prompt engineering. And so that's sort of the flow. The only thing missing from this is the metadata separation. That example I said about incident, like I might want to pull out, who look at the incidents, the day of an incident, and not put that stuff in the model itself. And so when you talk about the vector databases, there's three things you need to understand. One is index. So an index is really just, think of it as a data set. Like my book now is an index. I could take the Phoenix project and put it in, if Gene would give me the PDF, which certainly he wouldn't, I could put that, and I could have multiple vectors. And then I could have, like in a Mongo scenario, I could have metadata outside of the LLM and say, tell me about all the books in IT Revolution's portfolio. And I might have each one an index, right? See the point? And then you can see how the meta thing. So the index is the database, and you get to choose. Like one of the things I want to play with is break my book into chapters and make each one of those an index. So the point is, you have to play with this. Like you don't just like slam the data into something. You've got to sort of work through, like, how do I index it? How do I build the chunks? I'll show you some example. And at the end of the day, they all get vectorized into these 4-byte vectors. And that's how the similarity searches work. Math. And so this is like, I'm not going to sit here and explain the mathematics behind this, but it's basically what they call a nearest neighbor or approximate nearest neighbor. And there are other algorithms. But think of it as all these things like a dog or a cat or whatever. They're all in some vector. And basically, it's just math of how close they are. And if you want to learn more, man, there's more than you'd ever want to know about reading about this stuff. But the other good thing about all this is what I love is what's going on right now. I'm going to make up a number. Prior to basically a year and a half ago, 10,000 people who could do this stuff in the world. Now we can all do it. It really is. It's sort of the community data scientist idea. They've lowered the barrier to entry to do incredible things. And so this just quickly, the sort of embeddings. I know I'm getting a little deep, but I want to show you the tokens. Tokens are interesting. Like if I had a sentence, my favorite color is red. Depending on the encoding model, the embedding model, my will always be a 266 or 2266. Right? And so there's some interesting sort of map, but then depending on a different model, it might be different. And it really is about, is it like a nearest neighbor, it is an approximate, and it's about the algorithm that gets used to figure out how close the words, how close the sentences, how close the paragraphs, which ultimately gives my Aunt Tilly her answer about a recipe, or tells, you know, my uncle such and such where to stop when he's going on vacation and what stops to take, right? All the kind of cool things people are doing with GPT. So the chunking stuff is interesting. I'm going to skip this slide because it's a little too much. But again, what I want to say is the first step is, what is my data? What is my data type? I want to ultimately put it somewhere. Again, my book is my example, but it could vary. This actually started out with what I was calling anatomy of a video, where I took a video transcript and showed you how you could take that transcript all the way through, very similar to it. But I figured it'd be better to promote my books than somebody's video. So I got one laugh. Man, thank you. You can laugh, you know, like that's, I know it's technical and stuff, but it can be funny and like deeply dense technical as well. So there's like these chunky sides. So this is just Python code. Now there are certain libraries and sort of functions that do things for you, but at the end of the day, you can write your own code, right? But like there's some, like this is what they call the character tick split. So it's just give it a number, and whatever you read in, this would be every 256 bytes, it create a chunk. And remember, chunks are sort of located in the vector. It's the tokens that identify where. So this is what, you know, if you don't, I have found, like, if you don't really have, like, dense data or very well formatted data, like my book is reasonably formatted. It has chapters, it has headings and sections. I wouldn't use this, and I don't use this. But, like, if it was straight data and it really didn't have a whole lot of format, maybe even a transcript, right? Because sometimes even the best transcribers, like, are terrible. The second one is Markdown. A lot of people are starting to use this more often because you get a lot more control with Markdown. So one of the things I've been playing with is so I'm trying to help TechStrong, which is the Dallas.com, turn all their videos and stuff and content into a reasonable LLM. But I found out, you know, first they were like, go ahead and do this, and I'm like, no, we got to step back and we got to understand the data. And I'm finding if you take a transcript and you run it through a post-process to turn it into Markdown, you can add more data, and then it's actually much cleaner now in terms of like how it gets read in with the Markdown sort of chunking strategy. So it's really there's a lot of data types that are not well formatted that if you wrote a quick post processor, you could put them in a much stronger format. Because what will happen is like a heading 1 or a heading 2 or a heading 3, those become meaningful. So if you can kind of turn a transcript into meaningful like structures, like who it is, the name, who spoke, the timestamp. Like if you built that into Markdown, it actually becomes, you'll find that you'll get more value out of the prompting and the questions you ask, the more time you spent on figuring out the data. And that's the key to this presentation. Is like if you're going to do an enterprise, you're going to take all your SOPs for your airline, right? Like don't just throw them in there. Like go through this process, and this presentation is sort of a first cut at like what you need to think about. And then the one that I use mostly is this recursive chunking, and that basically is an algorithm that's basically whatever number you get. I said 250, and that's actually too low. I just paste this from the Pinecone documentation. But what it'll say is, until I get to 256, I'll look for end of sentence. If I got more data, I'll look for the end of a paragraph. I'll look for an end of a, and it's really just basically it has the new line functions to basically do that in the code. So you can do that yourself, or you can use this recursive splitter. And so this is what I use, and if the demo guards like obey, I'll show you how I can run the whole thing. And then this is just an example of using a chunk size of 1,000 with 200 against my book. And this seemed to work really well. And the 200, the overlap's interesting. What you don't want is when you're cutting it up, you have this idea of an overlap. I don't want it to cut a sentence midstream. Maybe it's incredibly important. It's like the most profound sentence in my book. And it cuts it right in the middle, and it's in different chunks. I've just lost a lot of efficacy in anybody trying to ask a question that might need that answer. So you generally put an overlap. And then, again, you got to play with this. Turns out 1,200 works pretty well, and I won't go through all this. But like another example, it was terrible, which was 500 with 20. And notice like chunk 3 just cut everything off, right? Because it sort of overlapped and ran out. You know, so that's my point. And this is just code. You want to go through this process when you look. And so if you're going to take like all your incident, all your SOPs, or all your risk control documentation, or whatever you want in your enterprise, you need to spend some time of sort of data strategy and engineering to figure out like prototype, just like you would do any scalable architecture, right? And spend a lot of time, and this stuff is easy. It might, if it's all new to you, like, oh my God, John, this is terrible. Like, if I can figure it out, you can. Trust me on that one. And then I talk about the embeddings. So the embeddings are interesting, again. So the whole idea of the embeddings are how data is stored in the vectors. And remember, GPT-4 is just a large vectorized database. It's a really large vector database. But like, and then you sort of can use your sort of optimization. So one is, how do I carve the data to optimize to put it in a system? Second is, how do I pick the right embeddings to match it based on, do I want it to be search-based, cluster-based, recommendation-based, anomaly-based? Right? These are all things you want to think about, like the type of data. Like incident, you might want to sort of lean towards anomaly detection. SOPs, you probably want to be search-based, right? And if you hate this presentation, blame Mike Rosato. So here's just the default. I wasn't going to go through all the different embeddings, but for GPT-3.5 Turbo and GPT-4, basically the text embeddings Ada-002 is the default if you don't specify it. So, and then all you're doing at that point is you're taking your open API key, in this case, it could be other than OPI, and you're just saying, whatever data you chunked, now go ahead and basically turn it into vector data. Right? And it's going to do all that magic of like putting the mathematics and the three-dimensional numbers and all that good stuff. And again, another reason I like Mongo is like if you look at, I've been playing with Pinecone, and Pinecone is a really good, and it seems to be the one most people are sort of gravitating to now. But Mongo, they built it from an enterprise thinking, right? So a lot of things we expect from a product are just showing up, and I'll show you some of their graphics too. So you can see a maturity there. And then I believe there's going to be a higher level of maturity. And in all transparency, I'll probably wind up doing some consulting for them. So just be clear on that before I go too far and tell you how great they are. But the point is, I think in their DNA, like companies that didn't exist 2 years ago, when they get into JP Morgan Chase or one of these large banks, I think they're going to learn a lot of things that a company like Mongo or Redis has learned over the last 10 years, right? And then there's already the UI and stuff like that already sort of, they look and feel the way we would expect the data to behave. And I tell you about the metadata. So that's basically deciding what I don't want in the model, and I want outside of the model. Now, some people before Mongo just wrote their own JSON objects and put all that there and then said, here's the pointer to the embeddings. And the, Pinecone has a very sort of simplistic, on the index, you put labels. And depending on what you need, I mean, Pinecone is an excellent product, by the way. So I just, I found for the stuff that I work with, I like the idea of a Mongo document object. But yeah, and then this is the Mongo. So basically, I couldn't find a great picture for it, but this is probably the best one I can find. The idea, again, like I said, is each index is actually really an embedding inside the JSON document object. So then you put all your sort of metadata outside that embedding. So if I did that search, like give me all the incidents Bob created last month on Monday fires that are P1s or P2s and deal with network. What it would do is slice through all the document objects and pull in all the embeddings, and I get one big fat embedding. And then I could ask all sorts of questions like, what the heck did Bob do? Why did Bob break the system? That's not DevOps. So. And then what's called the query chain. So now we've gone through. You've got to take some data. In my case, it was a book. I read it in, the text, the PDF. And there's a bunch of loaders. Like I said, there's loaders for just about anything you think of. Then I have to write some code to what they call chunk it, split it and chunk it. And I'm doing that for optimization, making sure, maybe looking through, make sure that like it's not making terrible decisions on how it's splitting it up. Did I write the right size? Is the overlap the right overlap? The higher the overlap, the more waste. But the lower the overlap, the chances are you might have, mutated data. So once you've got all that, now you've got it in your vector database, you've put your indexes, now you're going to do your sort of ChatGPT-like stuff. Now I do it all in code, either conversation or sort of what they call one-shot or a few-shot, but there's another decision you have to make, and again, this is like if you're going to do this at scale in your organization, you have to think about all these things. And tough that you have to figure out all these things, because nothing great comes easy. But it's not that hard anyway. So there's 4 different models. I'm only going to cover the first 3, but I'm going to show you what it looks like with my book. And this is the point. I used my book to find out what was the best chunking strategy, what was the best vector data store, and now I'm going to say when I'm actually going to query my book, which is the best chaining. And chaining is like how you take your query and you put it in a prompt and it gets sent to the, and it's not just the LLM now, it's your sort of vector database in front of the LLM. And so stuff is the simple one, and it basically, it's kind of hard to read, but it's basically just going to take your prompt and make one call, right? And so the upside is it's very simplistic. There's not a whole lot going on. You've got a good tight relationship. So if I ask, when was Dr. Deming born? Like, I'm going to get a really clean answer, right? There's no sort of superimposed interpretation. Now, MapReduce is if I actually needed, to actually put in a lot of data, there's a limitation, what they call context window, which is actually the amount of tokens you're allowed to use in a prompt. I have a limitation. I think GPT-4 is like 8K on the default, right? So I might say, well, I got way more than 8K, so what I'll do is sort of let it split up in a MapReduce-like model, and it'll sort of paralyze the thing. And then it will summarize it. Again, there's a little bit of a trade-off on the efficacy of the output, but the input of have a lot more than 8K to put in. So these are all benefits and trade-offs. The other 2, I'm not going to go over map rank, but refine is interesting. I find that when I used refine for my book, it was terrible. It hallucinated. Like for other things, so what refine does is you take your prompt, and it will basically try to summarize the prompt to get a better prompt. And in some cases, that might be really good. So again, the point I'm making ad nauseum is that you really need to understand the data type and this pipeline, this level of data strategy to find out what all these choices will happen and what's the most effective way to provide a service like your own, XYZ Corp GPT. And so this is an example of how I ran the different versions of the query model. I did stuff, and I'll show you the output and like what I got, the difference I got between stuff, refine, and MapReduce. So remember, my book is loaded, it's been chunked, it's in a vector data store. In this case, it's in Pinecone, and I've gone through all this. I set up the ability to set the query retrieval type. And so this is what the difference between stuff, refine, and MapReduce for the same book in a simple query. So stuff looked pretty good. The book is about, it was about Deming, blah, blah, blah. But the second one went nuts. The Fetus Project is an insight written by, like, the goal, and he wrote, like, it's... So, like, I wouldn't have known that unless I took this strategy to find out, like, I'm probably not going to use refine for any query in my book. Now, in another example, like an incident or something like that, refine might have been better. But you won't know until you sort of run through this. I'm trying to build a GUI that can do all this from a GUI. Right now, I'm just throwing it in a Markdown editor. And MapReduce worked pretty good, but I didn't need it. My queries were so simple, because the penalty for refine and MapReduce is you're making multiple calls to the LLM. And there is a cost. If you're turning this over to an enterprise, and you're going to have thousands of people using it, you want to keep, remember that cache thing I talked about? You want to keep thinking about how do I reduce my cost? They call it a token cost. And one is you can just run Llama 2 on your own server, right? And buy your own NVIDIA cards if you can actually be granted enough to get one, And And then sort of the last piece, actually it's going to look, oh, the demo thing, I might have time. Just quickly, Pinecone has a very simplistic GUI. This just told me how many tokens my book has, or how many vectors, but basically that's tokens. It gave me a little bit of sense on a query, what the transactional times were, but it was just honestly terrible, from what we expect. They do have a Prometheus plugin, so that might be interesting, but the data sucks. Sorry to say, as far as I can tell. Right, but what I want to see, so MongoDB, actually, again, this is more like what we expect. So it would be the same data in the same vector data store with all the same strategies, and now I get a lot, and this is just one of many screens. I get to sort of see, and now what I can do is I can play around with prompts, I can ask questions, and what was the efficacy on this? I can now tell what the cost is going to be, what my sort of resource, latency, all those things can start. And one other thing I haven't mentioned, what might be more effective is using something like ChromaDB, because ChromaDB is not a SAS. Every other one is a SAS. So there is a latency issue of using Pinecone or MongoDB or Milvis, because they're all SAS-based. So you're actually having to go out to your vector index, whereas there's in-memory ones, and Chroma is a really good in-memory one, where I could build that right on my own server, and not paying any latency cost or no token cost either. And this is the coolest stuff there is right here. This just was released. It's on. You have to get on a waiting list. We got lucky because we were running the hackathon last week. What's his face? The guy who wrote LangChain gave us the access to this. It's called Linksmith. And basically, it gives you detailed traces and timings of everything in QA. Because here's what you're going to find if you start playing with this. You'll run prompts, and you're like, why did I get that answer? What this will show you is all the stuff that's going on in between, because sometimes depending on what you're using, like LangChain, it might be making a call before your call. You get to see all that, and then you get to see how many tokens, because how many tokens you use are going to be really important. How many tokens you use on input, output, the total cost is what you are allowed to use. And then it will show you the timings. So this will get, if you're following this thread about I have to think really carefully how I might want to use my incident data or SOP data or my risk control data or anything, you're going to have to do this full line of learning how to, just like any other data and engineering. There's no simple solution here. And again, Linksmith, there's actually a trace callback that Linksmith uses. I'm trying to get them so they open this up with non-GUI and make it as just a pure trace log, because then I can use this in Prometheus. But so I might actually have to upload. Here's the funny thing. For 10 years, I used to code all the time when I was younger. For 10 years, I didn't code. Last 4 months, I've coded more in the last 4 months than I've coded in 10 years, thanks to Copilot and ChatGPT. And then there's this Y Labs. These are ex-chef people. It's interesting, and it's pretty impressive. So they do observability for large language models. But you can do this yourself. Again, if you got Linksmith, or you use this callback code, and if anybody wants this code, just reach out to me. I'm going to make it public at some point. I guess when I'm not embarrassed to show my code, then I'll go ahead and make it public. I can't believe you set a variable name like that. All right, the demo gods. Let's see what happens here. So what I did is I tried to pre-bake this a little bit because I didn't want to have. I use Google Colab. My apologies to all the awesome Amazon folk in the room. It's just that Google Colab is just so simple for Jupyter notebooks. So, but we're going to fix that, right? Fair. So anyway, just to go quickly, yeah, it's basically a bunch of installs. I got one of the things. Shannon Leach, if you don't know, she's incredible. She was at the hackathon, so she got. There's no documentation on this, but she got Google Secrets Manager working with Google Colab. That was beautiful, because I don't like my keys hanging around in all these weird places. And one of the things you can do with that, you can mount your Google Drive. So when I have my book, my PDF book is on my Google Drive, right? And then I load the secrets from Google Secrets Manager. I go ahead and grab all those secrets. This is the setup for Linksmith, which is that tracing tool. Here's the embedding. So this is basically, notice I didn't put an embedding on it. It took the default, the ADA 200 one, right? So, but I could say the embedding I wanted. And then I've ran all these ones. And then this is loading the, this is actually pulling out from the directory my book in a PDF, loading it in. And then here's my splitter. And I think I showed you. So I'm using a chunk size of 1,000, and I'm probably being overly cautious with an overlap of 200. And I'm using what's called a recursive character split. That's the one that looks for a sentence first. It tries to hit the max, in this case 1,000, goes by sentence, paragraph, page. And then I just wrote a little routine to show the chunks. Ultimately, I'm going to put this in Streamlit or in a Flask or something like that so you can just see this. I run the split, and here's, I showed you this. These are basically, I took the first 5 objects that, basically there's like 300 objects. This is my whole book, sort of chunked up in 1,000. Then I load the document, and here's where I put it in Pinecone. Now, another thing about ChromaDB, I don't need keys or anything. I just install ChromaDB, I run it, it runs local. Any of the SaaS-based, you need a key, and you have to sort of coordinate. Like in Pinecone, you got to coordinate with the index. Same thing with Mongo. But here, if you notice down here, this statement right here, right? So what I'm doing now is I'm saying the data that I chunked and the embeddings now basically turn that into a vector. So the embeddings that I specified earlier. And then this is something that's set up for LangChain. And then here I'm setting the variable for chain type. Remember the stuff, refine, and then, did I run that already? Yes, all right. So here, let's see if I do stuff. So this is like doing a ChatGPT here, right? It's looking at the vector database, and that's how I got that one. It said the book is a modern respelling of the best-selling book, The Goal. That was terrible. That's not what I should have got. That's interesting. Yeah, no, sorry, I'm not available right now. Let's see what refine says. That was interesting. A little bit of latency issue here. Okay. Oh, yeah, that's why refine's taking so long, because it's recursively calling the LLM. It's trying to figure out the best answer. And then it came back. And see, that one's terrible. I'm going to not run although MapReduce will run pretty quick. But then a couple more, so I'll do this one, and then we're pretty. So this is more of the type of questions I would ask. Like, so go ahead, give me the top 5 things about my book. So this could be a video transcript, it could be an SOP document, it could be a set of blogs that you wrote. Like, and the beauty is, except for like this one, it was sort of hallucinating on stuff which it normally doesn't do. But in general, it's not going to hallucinate because it's going against your data. And by the way, if you can trust Mongo, SAS, or Pinecone, the data that you ask questions it won't go escape to the OpenAI or whatever. In other words, you're sort of keeping a tight loop or a gap on your data. Now, that's assuming that you trust them as a SaaS to not be pwned, or you could just run your own, internal vector data store on your own servers, and then run Llama 2, and then it will never escape. Now, one other thing I want to say, like I'm probably going to get kicked off stage here, there's concern about using OpenAI and all this stuff. Right? So OpenAI in April this year made a commitment. They used to train on all data. So it means whatever you asked them, they were training. So you probably heard the horrendous story of, this is interesting. They don't know what they don't know yet. They need a bunch of you to go work for them. But they basically, it was a CVE in a Python async library that showed up in Redis, and they were using Redis so what happened is people's prompts, like your prompt showed up on my prompt, and it was a known, and I wonder if that, because Microsoft runs an OpenAI implementation, Azure OpenAI, I suspect that didn't happen there. Because I'm not saying they're great, but they were probably better at running scans against CVEs, right? These guys literally took a known CVE and it just propagated into Redis, which became part of their cache buffer they were using for prompts. Now, they don't train anymore. It's in their license agreement. Because April, if you use the API, they will not train on your data. And you can opt out training on non-API data, so there's an opt out. But and there is they do save prompts, and that's for to see if there's any malicious activity. But you can turn that off too. You can opt out of that. So again, if you trust, I would say that if you build a vector data store and you trust the SaaS and you sort of isolate on your data with your prompts, chances are you're not going to have this issue that all the scare tactics people are using about your data just showing up anywhere at any time. And then, yes, so these are the answers. And that's it. I hope that was helpful. If you have any questions, I know it was a lot, but I think you're going to have to think about this stuff. And maybe you learn a little more and go back and watch this video again. Because the thing is, you're going to have to be playing with stuff. You will be playing with the stuff. Like, that's inevitable. The question now is, you know, how are you going to treat it? You're going to treat it like a toy, or you're going to treat it like a strategy? Thank you so much.
Hey, John, you want to take a couple questions?
Yeah.
All right, we got time for 2 questions, so I need 2 really good questions. Who's got
Got to be really good questions.
Really good questions. All right, I got one here.
But they can't be ones that I can't answer neither. So.
Right, ones he can answer. Hold on.
Stand up and use them. Yeah. All right. Yeah. Earlier you talked about tokenizing your data and having it embedded, and then keeping your metadata in a different place, right? So I imagine for the embedded part, you use, and if we're talking about MongoDB, then we're talking about using an embedded strategy versus what would you use for your metadata? Would that be more like referencing?
Yeah, I think I think JSON objects is probably the best, but it could be anything. Like it could be a keyword value, it could be an enumeration table, but so the point is the embeddings are the vectorized stuff that you ask those exotic questions. Like if I want to say in my incident thing, it would be like, who did Bill talk to when he was in the war room for this incident, right? That would be not something that would be separate. That's something that would sort of use the nearest neighbor search to get me that answer. But to get the right vectors, I would store the name of the person, the P1 or P2 category, the category, all in a JSON object. So that I could search through the JSON objects. Now that could be any JSON object, it could be any, like Redis has an implementation that uses Redis implementation. So just the idea is I'm going to use classic mechanisms to find the embeddings. So it's like, think about like there's 5 GPT-4s out there, and one has about healthcare, one has automotive, and one has whatever, like pharmaceutical, right? Maybe I only want the pharmaceutical one. So I would use, instead of like just asking all 4, I would say just give me the pharmaceutical one, and the identity of that pharmaceutical one would be separated out from what's in the model. Does that make sense? Yeah, and so I just find that Mongo has done such a good job of already had this structure of document objects, so I can just slice through it and I get all the embeddings that are going to match the questions I want to ask the LLM, or in this case, the model.
Excellent. Thank you for your question. Do we have one more? Here we go.
It was a great talk, really enjoyed it. This is like my first introduction this year into mostly like ChatGPT and all of that. My question is how, when you test it and validate the data that goes in, how do you validate the data so you're not getting like bad answers? The 2 times I've used ChatGPT, it confidently gave me wrong answers.
Yeah, so here's the thing. So one of the things is you minimize the wrong answers. You don't completely eliminate, but you minimize the wrong answers with vector data stores, right? Because what you're doing is you're preceding data that you know is correct, and then you're sort of coordinating the right prompts to ask that data. But the efficacy of those answers is important. And so remember that 3-layer cake diagram I had earlier? So what you want to do, and it's this idea of multiple operation experts or something like this. So one of the easiest way is if I've got, let's say I've tested my data, I've gone through, let's say we're using SOPs. And I've taken like 20 questions and I've got the answer, and then I store those. Now I make changes to the model. I have another LLM that is specific, it's called a critic, that's specifically defined to see if I still have the same efficacy and if the answers are similar. It's actually a reversion of a similarity search. In fact, another example is using what's called the FAISS, which is Facebook's sentiment analysis. That's actually not even using an LLM. So what you want to do is have they call them evaluations. So you want to set up something at the end, and that's sort of your last test, is am I still getting the same efficacy? And you can make FIS be percentage-based. So I say it was 97.9 of all the 100 questions I asked this time. Let's check it again, whatever changed. It's still 97.9. then like I know that, and you know, that kind of stuff. So you're going to see it's different than ML ops or AOps, right? Because that was about sort of working and timestamping and thinking about the data and breaking the, you know, sort of keeping evidence of what you were doing. In a lot of cases now, it's more about, like our pipelines are going to be more about, like the example I said, could I generate proprietary code at this point? And if I can, something went haywire. If I could actually, if there's a 100-line, billion-dollar generating revenue algor code, and I can generate that after it gets a pipeline, somehow that code got through the system, right? That kind of stuff. So that's the whole new way to think. And then the other thing is interesting too. I didn't have time, and I'll stop here in a second. But the other thing that's sort of emerging is you use multiple models to so you might have 3 models, and then you'll have sort of a main model to validate. So you'd be using these sort of structures of like, okay, all these answers seem right. Let's go to the sort of the main one to see if it's valid. So you'll see a lot of that stuff really emerging. Anyway, thank you so much, y'all.